looking at, again, as I said, is what happens if you can't factor it. Well, obviously the first step is, in order to find the key features and sketch it, is we need to use a quadratic formula to start with to find the intercepts. So the first thing that we're going to do that is we're going to set y equal to 0. And when we do that, we end up with 0 equals 3x squared plus the 3x minus the 4. Again, we bring out our quadratic formula, and I suppose I would be nice and even give it to you on a test, just because I'm nice, because that is something that you could always look up if you really needed it. Okay, so we have our b, so we have negative 3 plus or minus 3 squared minus 4 times 3, and be careful, it's a negative 4, and it's all over 2 times 3. Okay, again, when we're actually calculating this, we have negative 3 plus or minus the square root of 9 minus, no, it's going to be a positive 48 over 6. Now when we do this, what we end up with is negative 3 plus or minus the square root of 57. Now the thing is, 57 isn't a perfect square. So that tells you right there you couldn't have factored it. So what we're going to do is we would take an approximate root of the square root of 57, and we would end up with 0.8 and negative 1.8. Okay, so again, these are approximate for our x values. So now we found the x-intercepts. Okay, and actually I probably should have put x-intercepts is what we're finding. We didn't find the y. Okay, to find the approximate axis of symmetry, well, it's going to be between those 2 points. So I'm going to actually do the same thing that we did in the previous page, is we're going to add those and take the average of them. So we would have then 0.8 plus our negative 1.8 divided by 2 for approximately, remember, negative 0.5. So the axis of symmetry is approximately x equals negative 0.5. Okay, now because we're only using approximate, it's the same thing here. It's going to be the approximate y-coordinate of the vertex. So what we do again is we take our original equation and we're going to substitute in our x value of our vertex. And when I do that, 3x minus 4. When we do that, we end up with 3 times negative 0.5 squared minus 3, again, times negative 0.5. For some reason, it just doesn't want to write on this side of the page. Minus 4. And when we do that, we end up with approximately negative 4.8. So from those pieces of information, we know the vertex then for this parabola is going to be negative 0.5 and negative 4.8. Oh, come on. I said it really doesn't like this side of the page. Okay, so now we have the vertex. All right, so now you can do a rough sketch of the graph, include the 4 most important points. So we know our vertex, we just found it, was negative 0.5, and I've forgotten already. I have a very poor memory sometimes. Here it is, negative 4.8. We know our axis of symmetry is x equals negative 0.5. we know that this parabola opens up. We'll leave our domain and range for a second. The same with this. We know our x-intercepts are approximately 0.8 and negative 1.8. And to find this, the same thing, we would take our y equals 3x squared plus 3x minus 4. And when we do that, this becomes 0, 0, so it's going to be negative 4. So we'll fill these out in a second. So our vertex is approximately negative 0.5, negative 4.8. Negative 4.8. We know our axis of symmetry goes down through that. So here it comes. Yes, the sound effects are free. So we know that, and I think I'll make that just a little less thick so it doesn't take away. There we go. So I know that is x is negative 4, sorry, negative 0.5. Okay, x equals negative 0.5, and we know it crosses at 0.8, which is over here, and negative 1.8. So this is 0.5. So somewhere like this. Okay, so we know that is 0.8, and this is negative 1.8. We could also put our x is negative 4, which is approximately here. And we now have enough points. Actually, I shouldn't have put a bracket around that. So it's gone. Negative 4. And it's just a matter of drawing a smooth curve between there. And we'll switch to a blue just so that you can still see those points that we have. So here we go, and up we go. Okay, so there's our parabola. And now it's much easier to do our domain and range, so let's go back to that. So our domain in this case, again, x can be anything, so it can be any real number. Y also is a real number, however, it has some restrictions to it in the sense that we can see that y will never go below this point, so we never can have a negative 10. The lowest we can go is negative 4.8, so y has to be greater than or equal to negative 4.8. And our minimum or max, in this case, we have a minimum value, and it is the vertex value of the y, so negative 4.8. Okay, so the next thing that we're going to look at is what we call intervals of increase, decrease. In other words, places where it's positive or negative. So once you have a rough sketch of the graph, you can find these intervals. For intervals of increase and decrease, the vertex is important. Okay, it's the changing place. It's where things change. So the interval of increase, as you look from left to right, so when I'm looking this way, the function is going up. Okay, you can see as I'm going, it's going up. When I go from left to right here, you can see that it's going down. So actually, when I'm talking about my intervals of increase and decrease, when x is less than the negative 3, sorry, put it the wrong way, less than negative 3, okay, so from here this way, so less, it is increasing, and from when greater than negative 3, you can see it's decreasing, it's going down. Okay, now next page. And we didn't need to do a mute or anything like that. All right, the next one, same kind of thing. For positive and negative intervals, the x-intercepts are important. Okay, so when we're talking about increase and decrease, we're concerned about the vertex. If we're talking about positive and negative intervals, the x-intercepts are the important things. And you can see that they're actually put there. So positive, and I'm just going to switch to my writing pen again. So for positive intervals, above the x-axis. And when we're talking about negative, and we're going to put something in here, when we're talking about negative intervals, we're talking about below the x-axis. So that's why our x-intercepts are so important. Now you can see that above we're looking at here is above, right? So we're looking at x fits between two numbers. And the two numbers it fits between is, from our graph, if we actually looked at it, approximately negative 5.8. You can see that. So negative 5.8. And this one is negative 0.17. So approximately negative 2, 0.2 roughly. Okay. And if we look at where it's below, okay, just watch your signs here. So x, first of all, would have to be less than negative 5.8. Okay, and so that would take care of these ones. And also x would have to be greater than, because we're talking about x's, x would have to be greater than our 0.2. Okay, so just be really cautious of that between positive and negative intervals, which deals with the x-axis, compared to when we're talking about intervals of increase and decrease. Okay, so lots of work for you to do.